and welcome to Aerohive's End-to-End QoS, or No QoS at All presentation. QoS is an acronym for Quality of Service, which you likely already know or you wouldn't be watching this highly technical video. My name is Devin Aiken, though my friends call me Devinator, and I wanted to spend a little time talking about implementation of QoS in a Wi-Fi infrastructure. I would like to quickly explain a little terminology that I will be using in this presentation. The OSI model has 7 layers, and it's common to refer to these layers by number, where we most often refer to layers 1 through 4 and layer 7. Network QoS markings happen at layers 2 and 3, and on the end devices, such as a server or client, it's layer 7, the application, that makes the markings. As a message flows through a network, devices such as routers, layer 2 switches, layer 3 switches, controllers, APs, and other devices may mark or remark layer 2 frames and or layer 3 packets according to their trust levels of the traffic being received and or their capabilities. In this presentation, you'll see and hear L2, which is a reference to layer 2, the data link layer, the MAC sublayer, Ethernet frames, and 802.11 frames. All of this is layer 2. You'll see and hear L3, which is a reference to layer 3, the IP layer, and packets. Sometimes people use the term packet generically, though, to mean a message being sent from one point to another in a network. More specifically, a frame is a layer 2 entity and a packet is a layer 3 entity, where a frame encapsulates a packet. But again, packet is the more generic term. 802.11e is an amendment to the 802.11 standard that introduced layer 2 QoS. And the Wi-Fi Alliance created an interoperability certification for it called WMM, which is short for Wi-Fi Multimedia. WMM and 802.11e are more or less synonymous. 802.1p is an old school holdover term that refers to 802.1q prioritization bits. The 802.1q amendment to the 802.3 standard specifies a 2-byte, that's 16 bits to you and me, Ethernet frame header expansion. Within that 16 bits is 12 bits of VLAN ID and 4 bits of priority. An Ethernet frame header is either expanded or it isn't. When it is, the connection is usually called a trunk, and when it isn't, the connection is usually called an access connection. DSCP is short for Differentiated Services Code Point, and lots of people just call it DiffServ. DSCP markings are IP header priority bit markings that are an upgrade to the original IP headers TOS, or that's short for type of service, bits. DSCP is the layer 3 priority marking mechanism we're going to be dealing with. Thanks for attending Aerohive's QoS presentation. We hope this has been helpful. Please visit aerohive.com/register to check out our free Wi-Fi network planning tool and Hive Manager online, and have a great day.